Hey guys, Steven here with the third episode, I guess, of our display tutorial. This might be a long one, so bear with me here. We're going to go through two different ways to add a a binary decoder onto our display. The first way is going to be the long way that's not very compressed. And the second way, which I'm not actually going to build in this video, I'm just going to give you a link to it, is the quick and dirty way. If you don't care about how it works and you just want to have it. But, me being the person that I am, I think you guys know that I like to explain stuff. So we're going to go through this, and there's going to be a little bit of math involved, but I promise I'm going to keep it easy for everyone. So first we have to do a little bit of explanation before we can dive right into this. So we're going to talk first about variables. We're going to have 4 variables that we hook up to our display. Okay, they're going to come from switches or levers, or they can be outputs from a calculator or anything else you want to display. So our variables can, well, for example, x. If we have x the variable, x just represents anything that can be on or off. And we call on 1 and off 0. This is just a way it's traditionally done. This lets us make equations about x. Like, if we say x and x is on, then we know that x equals 1. Or if we say not x and x is 1, then we know x is 0. Things like that. Next thing we want to talk about is a literal. A literal is any time we see the letter x or y or something, just counting itself, that is either normal or inverted. So we could have x or not x. So that's just a term that we use. I went over this in my rock, paper, scissors video, but I'm doing it again because I don't know if anybody actually watched that. So a minterm, in our case, is going to be 4 literals multiplied together to represent a number. So it'll be 4 letters in a row. We're going to use W, X, Y, and Z because they're consecutive, and they're the ones that are typically used in computer science for representing binary numbers. So anytime we want to represent a number, we're just going to multiply W, X, Y, and Z. Okay, just that's what it's going to look like. But really we're adding them, but we'll get into that. So here's an example of a minterm. 0010. W naught, X naught, Y, Z naught. Okay, that's what the apostrophe means, and it means for the one before it. So it's W naught. So if W is 0, then W naught is 1. So this is saying if we have a W, we want to make sure it's 0 in order for this statement here to be true. So basically, this is how we're going to represent, we're going to turn our variables into binary numbers with this methodology right here. So W naught, X naught, Y naught, Z naught is equal to 2. Just if we look at our minterm conversion table, which I'm going to show you in a second. And that's because everything is inverted except for Y. So this is going to equal 2 only if Y is 1 and all the others are 0. So in this way, if we have 4 levers and 3 of them are off, but the second to right one is on, we know we have 2. That's just how we're going to represent numbers. So here's our total list of minterms that I just put together. It shows you the binary and then what it is in decimal. So this is pretty simple. Basically, a quick cheat sheet. The first digit, if it's 0, is 0, and if it's 1, it is 1. The second digit, if it's 1, it's equal to 2. You just add 2 to your total sum. So for example, here we have 1 plus 1, which is 1 plus 2, which makes 3. And that's basically what we're doing here. So once we get to 9, we don't have any more single digits we can use, so we're going to use the letter A on our display to represent that. And the same goes up until F, which is the most you can represent with 4 digits, which is what we're going to put into our display. Okay, so 1111 is equal to 15, because it's 8 plus 4, which is 12, plus 2 makes 14, plus 1 makes 15. That's our F. So that's the most we're going to put into this. And if you want to have a bigger number than F, you just put 2 displays together, and you'll have 8 binary lines. So the biggest number you could do there would be 256. Or I guess 255 technically, but 256 different numbers. So what we're going to do is basically take our 4 inputs and calculate each of the minterms, or have the game calculate it for us. We're not actually going to do any math. we're just going to use our table right here to tell us how to build the minterm. So anytime we want to build a minterm, or build the number 0, we want 0 to be true if none of them are on. So what we'll do is, for each of our levers, we're going to build one of these little contraptions right here. This is the lever. If it's up, it's off, and if it's down, it's on. What I did was I inverted the signal over here. So this is what the lever is. Right now it's off. If we click it, it's on. The other is the inverse, which we got by using a redstone torch and building an inverter gate like this, a NOT gate. So to build the number 0, we want all the levers to be off. Well, this line right here turns on if the lever is off. So we can use AND gates on all 4 of these lines to build the number 0, and I'll show you how to do that. We're going to use this right here, which is a 4-input AND gate to do that. There may be smaller ones, but I like this because all the inputs are 1 apart, and the output comes out the middle. And then we would feed this number 0 line into number 0 on our decoder right here, which goes to the redstone display. So that'll display 0 if all 4 of our lines are off, which is what 0 is. So, it's weather that's happening right now. So this is going to be a bit tedious. I'm not going to show you how to do every single one, but I'm going to give you the table here and in the description. So if you download the map, or if you read the description of the video, or if you even look on Wikipedia or something, you can find out how to make each of these numbers. But I'll go through a couple of them with you. So I want to start this off way over here because I'm not sure how much space we need. So we're going to introduce some delay into our circuit by building kind of far away. But don't worry about it. We're not too concerned with that right now. So let's build, I'm going to put our, let's see, I guess we'll use signs later. So let's just start off with levers. In the next video, we're going to hook up a calculator to this device right here. But for each of these, I'm going to use a different color so that we can keep our bits straight. Or, we'll know which is which. So right now, we have to do this. So we see it switches between on and off. So here's one of them. The next one we're going to put 1 block away. I'm going to use orange for this. We want to put the whole thing 1 block away, meaning we have to do it like this. So we put our lever, and, okay, sorry. I'm messing this up here. Hold on. Okay, here we go. So this is going to be our next bit, and we're actually, the highest bits are on the left and the lowest bits are on the right. So this one here is going to stand for 8, okay? Anytime this is on, we're going to add 8 to our number. This one here is going to stand for 4. Anytime this is on, we add 4. So if both of these are on, we have 12, okay? And don't forget to put the line on top. And you can see these are all 1 apart, which is the way I like to do wiring in the game. So our next one is going to come to here. We're going to use blue for this, and this one is going to be worth 2, okay? And don't forget your redstone on top. You have to do that to get it to run to the torch. And our last bit is worth 1, and that's going to be purple for no particular reason, except that that was the order it was in my inventory. And so, yeah, this bit is worth 1. So if all these are on, we have 15. If none of them are on, we have 0. And then you have, 14 other combinations in between. So what I'd like to do first is we're going to run these out and pick off each of the values that we need. And these aren't going to line up perfectly with this display right here, or with this decoder, just because this one is very narrow and this one is going to be very long. So we're going to kind of do some wire acrobatics, and this is why I made it so far away, so we could do that. So let's build these out to 15, because we know we're going to have to go at least that far. And then you put your repeater down, and you'll just do the same thing for all these. Same goes with these lines. You're going to have to be kind of careful with these to make sure that anytime you take a wire that you're not preventing it from going into a repeater. So this wire has to flow straight into a repeater. If we do this, it no longer flows into the repeater and loses power. So that's going to be a very common issue that we'll run into while doing this. And then keep track of your online and your offline. Anytime you're trying to make a 0 minterm, you're going to take the inverse line right here, okay? Because it's the inverse of the torch. Anytime you're trying to build a 1 into a minterm, you're going to use this one, okay? And you're going to see what I mean in a minute here when I say that. I know it's confusing terminology, and it's terminology I'm actually pulling out of a dark spot of my body because I'm trying to be clear for everyone on YouTube, not just the people that know computer science, okay? And the other engineers. So bear with me. I promise you'll understand this if you haven't yet. And really the best thing you can do is educate yourself. Read lots of articles and things like that. Okay, so we have all of our lines accessible now. So let's build our first midterm. Let's build 0 because it's the easiest. We're just going to take from all 4 of the negative lines, okay? So anytime, let's go look at our midterm chart. So we want to build 0, so all of them have to be 0 in order for us to get 0. So we're going to use our inverse lines so that when the torch is off, the inverse line is on. So we'll just take, oh, this isn't the actual thing. It's over here. So let's start with this one right here. And we can actually run this from the ground. We don't need to run it over the other. The others, let's build them all one apart for our AND gate. So we'll just put a piece of wool over these wires and then run it down to the ground like this. And then you can take wire over this guy until it is beside the other one on the ground like that. And then our AND gate will go right here, okay? And that'll be true of all of our AND gates. They'll all run in a line like this, and then we have tons of room out here to wire the wires all crazy to get to the points. We just have to watch out for the signals running out, so we'll use lots of repeaters. So the next one we're going to take is we did 8, 4, we're going to take the 2 right here. This one has to be off in order for 0 to be true, or in order for us to have a 0. So we're going to run this one right beside the others. And this is exactly what we did with the rock, paper, scissors game. We are building a decoder. This is what you call a binary decoder. And there are more compact ways to do this, but what we're doing is understanding it. So let me be clear that this is not the super ultra compact way to do it, and I know that. People are very fond of trying to make themselves look really, really smart on YouTube. And although I am impressed by some of it, sometimes I really just don't care. So we can see this line ran out, so we're going to have to put a repeater. These are going to add a little delay to our system, but we don't really care. We also see this line ran out down here. We can't put a repeater here because it doesn't reach. We can't put a repeater here because it doesn't reach. So we have to put it here, and that will take it down to the ground. So now we can build our first AND gate, and let's make all the AND gates something. Do I have any cool colors here? Let's do red. We didn't use red for anything. So we'll ditch this black wool here. Do red. Oops, I accidentally did light gray. Red. There we go. Okay. So our red AND gate, it's going to go here. 1, 2, 3, 4, 5. And, oh yeah, one more on the ground right here. So we'll put a torch on top where each input goes in, like so. We'll connect all the torches with redstone on top. And then our end torch goes here, and then we have to fill these spaces in with redstone dust to get them all to connect. And we can see right now this torch is on because we have 0 entered in. But as soon as one of these lines becomes true, so let's turn on, now our number is 8. 0 is no longer true because this line is on now instead of this line. So we have, this is our W right here. We have W instead of W not, so, or not W. So we can't make 0 out of that. But we did it. It works. So now what we could do is, just to demonstrate it, move pink sheep. You don't even make sense in nature. No, there aren't pink sheeps. You don't make sense. I mean, there could be, but, you know, I don't believe it. All right. So we would just run this guy right into here. And we have to use a repeater because it doesn't quite reach. So right now we have our 0 line turned on. So let's go look at our display and see if it worked. It didn't for some reason. That's weird. Hold on a second. Let's check it out and see what we did wrong. Oh, okay, so I have the 8 line turned on still from my tutorial. Okay, let's go look at it now. Okay. Hey, it's 0 because our calculator told us so. Awesome! So slowly but surely we're going to replace all these. You can do 0 through 9 if that's all you want to do. I like to do 0 through 15 because it lets you display more answers on one display without having to go to more displays. Anyway, I'll do a couple more of these to show you, but then you'll get the hang of it, and you'll unfortunately have to do them by yourself. I know, I'm sorry. So the next one I would like to do, let's change our wire color so we don't confuse ourselves to yellow, just to keep things straight here. Next we're going to do is the number 1. So before we try to do it, let's actually key it in, and then we will pull from all the lines that are currently turned on, because that's how we make 1. When these things are outputting on, that means that whatever we have dialed in is what we need to AND together with our AND gate. Okay? So, and this AND gate represents our multiplication that we saw earlier. So for 1, we have 1, 0, 0, 0, or reading it from left to right, 0, 0, 0, 1. So, let's do the same thing that we did. We're going to build it one space apart from this guy so that we don't interfere. And again, there are more compact ways to do this, but I am not concerned by that right now. 1, 2, 3, 4, 5. How many are these? 1, 2, 3, 4, 5, 6. Oh, these are 6. Okay. So we'll have that one come to there. Alright, so the first one we have to do, the first one is the closest one. That's what I like to do first. Run this so we don't need to use any wool. Our next guy is going to be here. So we'll pull him, oops, not with green, with yellow. Like so. And I used the wrong wool color there, but it doesn't matter. Okay, so this doesn't make it, so we need a repeater on top. And this is going to happen pretty frequently, so we'll get used to it. Then we need to take, and this I don't think is going to be long enough. Maybe. Let me put torches and see. 1, 2, 3. No, we'll need one more block here. So we might have to do some creative wiring to get all these to reach. So our next one is going to be this one. Is that far enough away? Yes. Okay, let me drop that. And I have a feeling this one's going to run out really soon. And it does. So what we have to do is this. Look, this wire can't even make it up the slope. We can't put a repeater here. We can't put a repeater here. So let's just put one here. And then we'll knock this one out because we don't need it anymore. See? So this wire gets to go straight for further numbers. We're using all the same inputs for all 16 of these. So that one makes it. Next one we want to do is our last one, which doesn't quite make it to here. You know what, guys? We're going to have to redo these repeaters because they don't make it from the first part. That's a shame. So let me go ahead and do that for all of them before I forget. And that's just because the two wires start off at different lengths, but it's not a problem for us because we are pro. Okay, so we can't take it from right here because we know it's going to run out. So why don't we take it from afterwards, like this, which is actually perfectly lining up. And let's put some redstone down since we're not going to be able to build under this thing very easily. I think I'll do one more after this, just to show you. But you can do the rest of them. It's pretty simple, and I don't want to make like an hour-long video doing all of these. The hard part, I'm telling you, all this part's easy. Just test all the numbers. The hard part is going to be wiring up to the decoder. This is a decimal to 7-segment decoder. This is a binary to decimal decoder. Okay, these are the official names of these things. So this one also is not reaching all the way, so we'll put our repeater here. We can see all the torches turned off, so all the lines are reaching. So we put our 5, wait, is that 5? Yeah, 5 in front of it with our output, and then we connect all these on top. I love too many items. This is like the coolest mod ever. I'm serious. Okay, like so. So now we have 1 dialed in. Our output is 1. So let's hook it up to the decoder and kind of prove it to ourselves. Oh, what did I do there for? Whatever. This isn't like the best way to wire. I'm just kind of trying to get it there by whatever means necessary. Alright, so that one goes into it. So we know we have 1 dialed in on our thing. See, only the number 1 is hit. So our decoder should be sending our 7 segment the number 1, and it did. Haha! So if our calculator answer was 1, we would have 1 on our panel. So you can see this is quickly going to get very large. It's definitely going to be very large. But we see exactly the logic gates that are going into this. And this is the way you would have to kind of do things in real life unless you actually had a decoder chip. And I'm gonna show you at the end kind of a decoder chip that you can use for your purposes. So let's extend these out kind of far. And let's not forget to change it to, our next number is going to be 2. So let's not forget to change it to 2 before we start wiring, or we're going to take the wrong number. I'm already anticipating all the hate mail I'm going to get about this. I get a lot. There's a lot of people out there that apparently know way more about everything than I do. I guess there's a difference between suggestions and, oh my god, you're an idiot, you did that wrong. But if I did something completely wrong, I'm going to make an annotation about it. I'm not going to leave it up there just wrong. That'd be silly. Let's switch back to white. And let me max out my white so I don't have to go back in inventory for it. So, we're taking the number 2. Therefore, we ought to make our control panel on 2 so that we take the correct thing. We saw that 2 on our minterm chart is just the second torch lit and none of the others. Which makes sense to hopefully everyone. So our first one we're going to pick off is right here. This is going to go right into our AND gate. The next one we want is lit right here. And we'll take it from 1 apart, like so, to the ground. And make sure it reaches, and it does. Our next one looks like it's right here. And let me make sure that we're 1 apart. We are. This is my favorite way to wire things, because it looks like actual wires on a motherboard or something. And the way processors are wired up. Alright, so we see it runs out right here, so we have to put a repeater, and it makes it to the ground. And our last one is right here. Oops, not quite, right here. I tend to misclick rather often when I'm doing these, because I get a slight amount of lag from fraps. Oops. And then I go too far building, because I can't see what's behind me. It's a very, very difficult and troubled life that I lead while doing YouTube. Alright, so let's find, we need to put repeater here. Then we'll go make our AND gate out of, I said red before, right? So we put all these in a row, like so. And then another row of 5. Oops. Put torches where each one goes into the block. Oh, look, I was stupid, and I put these 2 apart. Okay, well, just don't do that, guys. It's pointless. Dang, that's stupid of me. Okay, well, this thing should still work, though. My bad. I messed up on camera. Everybody can go, oh my god, what a noob! So we have 2 wired up. Let's wire up our output to our display. Man, I made 1 mistake. It's better than I usually do, I guess. I mean, I probably made more than 1 mistake in explaining some of this computer science stuff, but whatever. We have a working decoder. Does it matter? No, I think not. So we have to do a couple. Let's do this creatively so we can use less repeaters. Okay. My family's home, so somebody's totally going to come in and wreck this video. I bet it's Scott. Hey, Steven, what are you doing? You doing a YouTube video? Hey, number 2. So, we have 3 numbers working on our decoder so far. So this will be, you know, like 5 times as long when we're done. Quite a bit long. But it works. That's the important thing, it works. And we have all this space to mess around with, and it's pretty fast. Well, we could bring our control panel further up. But you've seen on my other calculators, it's fairly quick. So I'll put this up in the save file, definitely put up the minterms for you guys. And I'm going to cut now to show you the really, really sweet decoder that somebody on the forums made for me. Okay guys, we're back. This is the, I call it the Banjo Benny binary to 7 segment decoder. That's the guy's name on the forums. You can see this takes 4 binary inputs. Seems to be missing a line right here. There we go. And outputs 7 segments that controls our display. So this does actually the 2 decimal and 2 7-segment conversion right within itself. I don't pretend to understand it. It's rather complicated. It's basically 2 decoders. On top, we go binary to decimal, and then on the bottom, we go decimal to 7-segment. And this outputs them nicely in 7 separate lines. And I will put up the save file so you can try to make this thing. I think there might still be a link to the forums from my old description, so I'll try to take that. I'm not going to build this thing for you because it's really tedious, and you can do it by yourself. And yeah, so definitely post your questions. I'm sure there will be many of them. And in part 4, we're going to hook this up to our calculator, adder, subtractor, giving us an almost full computer. And of course, after that, we'll delve into memory and processing commands in order to run our programs on our makeshift computer. So thank you for watching, and goodbye.